Alrighty guys, so we're not going to learn a new form of a line today, but we're going to talk about specific types of lines and kind of like when I have more than one line. So when we start getting more than one line on a graph at a time, a couple of things can happen. The lines might cross each other or they might not. And so if I'm posting this video at the time that I think that I am, it's weird because I'm doing this before I'm actually doing this. Sorry, I got a little existential there. We will have already talked a little bit about parallel and perpendicular and what that means. So let's take some notes on those things. I don't like spelling out the word parallel and perpendicular because they're hard. So the symbol for parallel is where you just make two little cute parallel looking lines. And the symbol for perpendicular is an upside down T. So if you want to use those cute little symbols as well, we are going to talk about parallel and perpendicular lines on page 61 and 62. Now, if you don't have your stuff all cut up in the notebook, if you just have the packet of things, it's actually on pages 15 and 16 and 17 that we're looking. So let's start with actually page 15, which looks like this one. So again, if I'm posting this video when I think I'm posting this video, we talked about how parallel lines are lines that never intersect. But more importantly, like what that means mathematically is that when I'm looking at the equation of a parallel line, like this I can see probably in a picture of a graph. I mean, to know that they never intersect, I'd have to see the whole thing, and lines go on forever. You can't see that. But you can probably tell based on some numbers. So I can tell that the lines will be parallel and never intersect as long as two things happen. Firstly, that they have the same slope. So like if one line has a slope of up 1 over 2, the other one has to have a slope of up 1 over 2. But they also have to have different y-intercepts. So on a graph that's easy to see because you'll see like a parallel line and you'll see a parallel line and they won't cross each other. And I can count the slopes to see if they're the same. And obviously they will not have the y-intercepts be the same. But when you're looking at the equation, it's sometimes a little harder to know if the y-intercept is the same or not. And it can't be because then it's the same line. If they have the same slope, same y-intercept, that's just the same line twice. So that's silly. So we need to have the same slope, but different y-intercepts. Same slope, different y-intercepts. So to check if lines are parallel, kind of the best way to do it, the best form to be in is y equals mx plus b. So first, get lines into y equals mx plus b. And then secondly, are the slopes the same? And are y-intercepts different? You need to say yes to both those. So a cute little example, if I'm trying to check and see if lines are parallel, maybe they give me line A as y equals 2x minus 1. And maybe they give me line B is, let's see, 4x minus 2y equals 8. I need to get the lines into y equals mx plus b. Luckily, line A is already that. I can tell because we got y equals a number with x and then a number without x. Line B, unfortunately, is not. That one's in standard form. So to get it into y equals mx plus b, we talked about this last time, I need to always move the x, so add or subtract the x. In this case, we'll subtract it. So we'll have negative 2y equals negative 4x plus 8 because it's positive. And then I have to divide the number away by y. So we'll divide the negative 2 to all these little buddies over there. And when I do, I get y equals negative 4 divided by negative 2 is 2. Excuse me. It's 2x. And then 8 divided by negative 2 is negative 4. And then I'm in y equals mx plus b. And here's my other line. And so when I compare the two, now I need to answer this question. Are the slopes the same? Yes, because they are both 2. I also need to answer the question, are the y-intercepts different? And the answer is yes, because that one's a negative 1 and that one's a negative 4. And that's a yes. As long as I get a yes on both, the lines are parallel. So, yes, parallel. Okay. Another thing that we can do with parallel lines is write an equation of a line that will be parallel to one that we already know. So for instance, write the equation of a line that is parallel to the given line and passes through the point 1, 5. So they have to actually give you a line to go with. So let's say, for instance, they tell me the given line is 3x minus, oh boy, 6y, sorry, equals 12. There we go. When they ask me to do a question like this, write the equation of a line, I need to write the new equation of a line here. So it's not going to be this one, it's going to be a different one that is parallel to that one and passes through the point. Okay, so the thing is, they've given me a point, and low key, whenever they say is parallel to a given line, that is just math code for your slope's the same as this guy. So this is math code for slope is the same as this line, whichever one they give to you. Okay, right? And that makes sense because if the lines are parallel, they have to have the same slopes. So they're giving you a line which has the slope in there somewhere, and then they're giving you a point that your new line has to go through. So the point that they've given me is 1, 5. I need my slope, and it will be the same as the slope from this one. The trouble is, I can't see the slope right now. It's in standard form. So I need to take that 3x minus 6y equals 12 and get y alone. So I'd subtract the 3x both sides. And then not combine those because they're not like terms. Then divide the negative 6 on both sides. And so I'd have y equals, so negative 3 divided by negative 6 can reduce to positive half x. And then 12 divided by negative 6 is negative 2, so I'll put minus 2. Oh, I was almost going to circle that, but that's not my answer. That's not my answer. Although it gives me a number I need. So again, write the equation of a line that is parallel to this line and passes through this point. Is parallel to this line is just code for your slope's the same as this one. So I went through and I found my slope, and it is half. So the slope of my new line needs to be half. And so when I write the equation of this new line, I'm going to write it in point slope form because that's what I have, a point and the slope. So I'll do y minus y1 equals m, parenthesis x minus x1. I'll put y in for y, so y minus 5. I'll put slope in for slope, so half, parenthesis x minus 1. Now you could distribute and put it into y equals mx plus b, but then you're going to have to deal with a half thing, and I feel like, why? This is a perfectly acceptable form of a line. It's all good. Oh my gosh, let's keep going. Wait, now I got to make a choice. Do we want to talk about... Let's actually not do the rest of this book yet. Let's jump over here. Write the equation of a line that's parallel to that equation there and go through the point. So if you're doing it in the packet, these are the next 2 pages. So on the very next page, page 16, is the parallel one that I'm looking at, but there's 2 of them. So you don't need to do both. They're the same. Okay, so we'll do that one. Alrighty, so this question here is just like the one we just answered. So write the equation of a line parallel to this one through this point. So again, parallel to is just code for your slope is the same as this one. And we're so lucky. The slope it's staring right at me. That's in y equals mx plus b. So that means my slope's going to be 2. And then we have this point here. So when I write my equation, if I want to write it as y equals mx plus b, I mean, that's fine, but I'm not going to do it right away. I'm going to put it in point slope form first. So I'll do y minus the y value equals m parenthesis x minus x, which is a double negative, so plus, because then it's super easy for me to put it in y equals mx plus b. I'm just going to distribute and then get y alone. So we'll have 2x plus 2, and then I'll add the 2 over. So we get y equals 2x plus 4. And the reason that we might want to do that is just to be sure that, I mean, I wasn't stupid and gave you the same line twice, which I didn't. So the line that they gave me was y equals 2x minus 3. The line that I found with the same slope but going through a different point is at y equals 2x plus 4. And so then we can really see that they're parallel by graphing them. So on this first line here, which I'll do in green, I would plot the y-intercept at -3. And then I would do the slope from there, which is up 2 over 1. So we get this line here. And then the line that I had to find that was parallel to the original one and had a y-intercept of 4, we'll start at 1, 2, 3, 4. And then I would go up 2 over 1, but I kind of can't. So instead I'll go down 2, back 1 to keep it positive. Double negative is positive. So there you go. If my lines weren't so swervy, they would look a little more parallel-y, but it's just because I didn't use a straight edge. I'll do it on the next one. Okay, if we open that up or turn the page, we have a couple more to try. I actually want to try this one in a little bit of a different way because the super interesting thing is I can do it graphically instead. So write the equation of a line that's parallel to y equals 3x minus 2 and goes through the point -1, -2. Now I could do it like I did the last one where I put it in point slope form, distribute, get y alone. My slope needs to be the same since they're parallel. But let me just think about this a different way. So if I go graph that first line, I would plot the y-intercept at -2 and then do my slope of up 1, 2, 3, forward 1. Let's get a straighter line this time. Okay. Now, with the line that I need to come up with, the line that is parallel to that one, it has to have the same slope, so it still has to be 3x. But this isn't the y-intercept. However, I can go graph that point. Like I can put that point on here and go to -1, -2. And then from there, do the slope. So up 1, 2, 3 over 1. And then I find my y-intercept, up 1, 2, 3 over 1. So now I can see that the y-intercept is right at 1. So I can put +1. And then we get our graph that's parallel. So that way, kind of a little easier, as long as you like graphing. I mean, I love graphing. If you rather do like algebra stuff, like that's fine too. That's kind of what we did on the front was like an algebraic method. So we get y equals 3x plus 1. And like there's no work to show because I did it over here on the graph. Okay. So for that last one, I would suggest maybe do it any way you like. So write the equation of the line parallel to and through the point oh, they did. That is not in y equals mx plus b. So I do not know my slope yet. However, that is the y-intercept. So that's kind of nice. So I actually know b. And if you remember when we talked about standard form, you can find the slope pretty quickly by doing negative a divided by b. But we could also do this another way. So I can take this line here, this 2x minus 3y equals 6 line, and find the x-intercept and the y-intercept. So to find the x-intercept, I solve for x by ignoring y, and I get 3. So along the x-axis, I'd plot 3. And then I would ignore x and solve for y to find the y-intercept is negative 2. Ooh. Oh, that I'm like, why is that not the same? That's for the other line, not my line. So 1, 2. And so this line is going to be right here. And now if I want, I could just count the slope. So the equation 2x minus 3y equals 6 is this first line that I've drawn by finding the x and y intercepts. And now I can really just count the slope. From this point to that point, I need to go up 2, forward 3. And now I know the slope of my line. And they told me the y-intercept had to be 3. So if I plot 0, 3, and then from there do my slope of up 2, forward 3, we get our parallel line to it. And that equation was y equals 2/3 x plus 3, which now if you remember that negative a over b, you can see 2 over 3 is the slope. So that's kind of nice. Blue, blue. We'll talk about perpendicular in the next one.